Okay, so next we have this really anticipated, exciting panel. So we can bring four chairs for panel members. Okay, in the front. Okay, put this on the side. Just take the middle. Yeah. And you have to pass this speaker on, like this one. You can leave one there. Yeah, Sam, you can leave one there. It's easier for people. Yeah. Yeah, sure. Anybody in the audience recording? Yeah, up to the okay, right? It's okay to record this, right?
Can we turn the projector off?
Turn off the projector?
Feather blanket.
Turn off, yeah. It's done for today anyway, just power off. Okay, perfect. Okay. Okay, we have only this one mic here. Huh? It's perfect timing. So, and I'm introducing, you guys know all our three distinguished invited speakers for their exciting talks, but I also have Sam Lindley, who of course run the session and ask great questions. So that's our invited panelists for today, okay? And the victims for these really hard panel questions. And so actually I will start with actually reading a question first. He's one of the great minds and started work on this called the binding terminology for partial evaluation and lots of other fundamental work, especially really hard type for really hard type systems. Okay? So yeah, I actually shared this with some people. Okay, so this is by Fritz Hengland. Okay, effective neural symbolic AI. Essentially, the old-fashioned symbolic second-wave AI from the 1980s, combined with the du-jour statistic and differential third-wave machine learning, okay, like now is expected by many to be required to move AI beyond the LLMs and the current trend. Which role can modern semantics-based techniques for manipulating programs play? So of course, presumably as part of the symbolic side, of course. Or that's the question, is the very notion of rigorous context-dependent semantics based transformations outdated and useless in programming now? So anyone want to start, or I would just pick up victims in order? Really hard questions, and this is covers all. I spent a long time trying to formulate this question, right? And finally, first, I decided to ask the steering committee, and here pops this great formulation, so I just use it. And anybody can also think of a follow-up questions. I have a few. Okay. How about Sam? Okay. Just use it.
Let's just use the handle. We only need one at once anyway, don't we? I'm not quite sure why I'm on this panel, but yeah, interesting question. I have seen the question already, but I'm not sure I have a good answer. I think probably, in common with several of the other panel members here, I'm rather sceptical of this whole direction. I certainly don't think what we have nowadays in terms of LLMs is really posing any risk to a lot of the kind of work we're doing. LLMs seem pretty terrible at program manipulation. They can do something, but then, well, you have to check that it isn't complete nonsense afterwards. So, yeah. Does anyone else have a better answer?
Okay, so turns out I have lots of opinions about inference. Even inference I haven't done before. But I have looked a lot at LLMs, done some experiments with program manipulation, and I think, like Sam was saying, they generally produce nonsense. So the only uses that I've seen that have been sort of halfway productive are combining old school techniques, things that have embodied semantic knowledge that you then use to check the output, right? So, for example, F-star is using these to try to generate proofs, but then, of course, they're in a dependent type system. They check the proof, right, which involves semantics. So at the moment, I don't really feel like LLMs are a threat. I mean, I appreciate the provocative question, but I don't think it's like going to throw out all of our work. I think what's interesting is how often LLMs produce anything meaningful at all, which suggests like they're just statistically generating text, right? And there's a lot of text you could sample. The fact that they produce meaningful text at all is surprising, and the fact that they produce it kind of more often than not is very surprising. And that suggests there is some semantic knowledge in there somewhere. And I feel like we should be doing something to try to extract that and compare it to our very hard, like very rigorous semantics that only produce the things we have told them to produce, but always produce something meaningful.
Well, I mean, Fred's question is quite loaded, right? It's clear what he... I'm going to repeat a little bit about what William said. So I design hardware. So sometimes I design hardware in this language called System Verilog. And I use Visual Studio. I use Copilot, and I do say make me an address generator which works like this, etc. But I also write these System Verilog assertions. You saw a flash of them in my talk. These are basically like LTL logic, but it's part of the System Verilog language. So I write the properties that I believe should be true of the generated circuit. So VS Code will generate some System Verilog, and then I run the model checker on it. It gives me a counter model. And I give the counter, it's a conversation. I give it back to a VS Code, and it fixes that error, and we keep iterating until the circuit as we generated passes all the properties. So it might still not be correct, but I'm in much better shape than I was before. So this is just the tip of the iceberg, and I think LLMs and where they go, and all the work that we do with semantics and transformations, these are things that we're going to use in concert with each other. They're going to magnify each other's capabilities and power. So I'm actually a bit more optimistic than Fritz. Next time I see him, I'm going to have a beer with him and try and convince him.
Yeah, I don't think I have much to add. I think I'm also surprised how good they are in many scenarios. Especially when I see students use them in courses. But I think it is important that we specify why or extract the specification out of a question to an LLM, right? Because once we have that specification, we can actually, in some sense, test whether that program or that transformation satisfies these kinds of properties. So it goes in the direction of what Satnam was saying, right? You have these kinds of properties in your mind, and then you use actually the model checker to verify these properties, but then you bounce it back to the large language model to generate maybe more different examples that would maybe satisfy these properties. But ultimately, I think it's sort of in concert with what we're doing. But I think in general, probably we should maybe teach students more to specify properties rather than write programs, because I think it's hard actually for students to assess the correctness of the program, right? So they use them sort of naively. And I guess it's sort of, that's the easy way, right? It's like you just ask, can you generate a program that satisfies blah, blah, blah. It's like a homework description. And then very often it is right, okay? But sometimes it's not. And it's much harder for a beginner than to assess whether that solution is right or wrong. And they don't have the right tools to assess whether it's right or wrong. So I think what our community can bring is sort of tools to assess whether these answers are right and wrong. And for that, we need, in some sense, specifications.
Thank you all. it's already more impressive than expected. Even start with Sam, because lots of us, some of us at least, have the same feeling as Sam has, right? Just didn't formulate, so he spelled out. And as they go, they each have to think more, what new and more, I should say. And I think really new things come out of this. So if I want to just summarize a little bit, but well, for one thing, I do want to emphasize, okay, what Satnam is saying is, I write the assertions, okay, and then get these LLM to check. And Brigitte says, oh, we need to teach students to write that, right? So think about that. But to be more concrete, I have these couple follow-up questions, okay? So we know LLMs hallucinate, that's why Sam isn't impressed. Or nowadays they try to make it have, try to justify their bad answers or good answers and give you really long answers. I feel like I don't have patience to read and try to grade a student's homework, right? Just write a lot of bullshit. Anyway, but how can, we can still try to use it to help semantic-based transformation, and the semantic-based transformation may help reduce hallucination, right? Is there some thought about how we could do that? By the way, audience can also, anybody want to add to the first question, right, in general? By the way, the people can come in, either a couple of chairs, let's put in here. Yeah, you can come in. Yeah, go ahead.
So, at the risk of severely embarrassing myself in front of 4th grade panelists, so a lot of the methods I see, a lot of method people propose about combining symbolic methods and LLM, I think falls largely into what I personally just say called the branch and bound idea. So the idea is you treat the LLM as a large random box. You don't know about semantics, but it's better than a random text generator. You hope, at least you hope. You have to generate a bunch of stuff, then you use a formal method to bound it, to weed out everything that's not good. And our hope seems to be that, well, the LLM somehow has some sort of understanding, at least for whatever method, about the semantic space that's working in, so it will generate higher quality, a random text of strings that we have, so the chances of having something that actually works after weeding out is higher. Is there a way to not do this dance? Is there a way that we, PL people, can sort of start to enhance the ability of LLM to actually effectively explore the semantic space, instead of doing this, trying to rein in a wandering child style of work? Do you think there's a possibility to more directly engage with the semantic space of LLM?
Hard question. Go ahead.
So I'm happy to respond to that and respond to something you mentioned about hallucinations, which is my first thought is that hallucinations don't exist. Because to say that an LLM is hallucinating is to say that it's producing something that's invalid. But hallucinations are indistinguishable from valid output. All the LLM is doing is producing syntax, right? And there's no way, we as a human look at this syntax and we impose some meaning on it, but there's no way to give a type to an LLM and say, oh, these hallucinations are ill-typed or something, right? There's no way to distinguish these two outputs. So I object to hallucinations. LLMs don't hallucinate. They produce syntactically probabilistically valid syntax. The interesting question is, why is so much of that syntax meaningful, right? It's more meaningful than randomness would suggest. And so we sort of hope that either we can figure out the underlying semantic model that the LLM has learned, or we hope that we can use this probabilistic space that is better than random in some useful way. A lot of work goes into looking at this as a source of better than randomness as a probabilistic space. So for example, the fuzzing community has looked at LLMs as could we use these for fuzzing better than random? And it turns out in some cases you can't. Actually, randomness is just better, and it's better on a lot of dimensions. You can find more of the things you're looking for, more bugs, and you can find them cheaper than using an LLM. So in many cases, despite the fact that it seems like it should be better, random is actually better. If we actually want to understand LLMs, what we do need is some way to try to interrogate what has the LLM learned semantically. Why is it generating anything semantically meaningful at all? And what is the underlying semantics it has learned? And I don't know how to do that yet. One of the things I think is old AI was focused a lot on reflection, on sort of self-understanding and reflecting on what the system itself knows and understanding itself. And this has This has not come up in the kind of new LLM space, and it seems necessary if we want to be able to interrogate what the LLM has learned, more than just look at its output, which is statistically generated syntax.
So I'm definitely not an expert in this area at all. But one thing, your question about how can PL help in this domain, I remember going to a talk, it must have been like 10 years ago, before the whole sort of big thing about LLMs and so forth. And someone had an example where they were trying to teach a simulated racing car to drive around a track. And they'd started off, they had a perfectly round track, and they were just doing random perturbations, and I think it was going through some sort of machine learning system. And it managed to kind of go around the track in a sort of rather wobbly way. Then they gave it a different track, and it just crashed immediately. Then they rephrased the system in such a way that the movement of the car, rather than being some sort of continuous thing, was specified using a little DSL. And they learnt how to instruct the car to drive using the DSL. And it drove perfectly round the circular track, and it drove perfectly round this other track. So I don't know what we need to do, but somehow combining some knowledge about domain knowledge about the structure of what we're trying to learn with these technologies, maybe that will help.
There are competing thoughts in my brain at the moment. Yeah, I mean, I think I agree with William, really. Like, right, what it's generating is sort of statistically generated text. And so you could think, of course, saying, okay, you know, while it makes certain choices heuristically in what it prioritizes in the next word or next sentence, or, you know, maybe we could use some kind of type checking in between before it outputs some kind of syntax. Okay. But it seems that they have empirically found sort of this great randomness, or I think it's a particular factor which I forgot, by which they kind of prioritize, like pick a certain element of the next prediction, and it seems to work very, very well. Okay, and so I don't have a lot of hope in some sense to add in directly sort of this semantic knowledge at these given points. I mean, also I think it's sort of probably has sort of escaped almost our sphere, right? I mean, because these models are very large. Who is by now implementing these models? Can a researcher actually implement their own model? You know, somehow I don't think that's a viable research direction to explore. So that ends up with, in the end, sort of saying, okay, they produce syntax, and we'll just accept that they produce syntax, and maybe we can figure out what the rules are that they have been doing. So we have used large language models to do type error prediction, okay, and for OCaml programs. Okay, I first thought that was the most craziest idea ever. So I came back from a vacation, and there were these 5 students who tried to use type error prediction, and they used these large language models to do that. And they had surprisingly good results. So they wanted to identify the true source of the error, okay, rather than OCaml doesn't give you the true source of the error. It gives you, it computes some constraints, and it fails at some point later, okay, and that might not be the true source of the error. And so it turned out in that case, they did want to know, like, did it learn some particular structure? And it did seem to have learned some structure. It didn't learn any formal rules, okay, that would correspond in any form to our typing rules. But it did seem to have learned some structure of these programs. Now, I don't know if that really translates, because a lot of it has to do with the data they are trained on. And so, you know, they work very well on languages like Python and Java, but if you have like a low resource language, and funny enough, OCaml already counts as a low resource language, then how does that actually translate, right? So we don't really know. Okay. And so I think that begs sort of also the question, how successful will large language models be in, for example, generating logical specifications? Okay, so there are some languages that are specific to model checkers, but there's not a lot of data out there to train these large language models on the specific language that a particular model checker would use, right? So then you can sort of say, okay, we'll introduce some kind of intermediate language and then we'll do some translation. Then we're back in the PL game, okay? If that gives us better results, I think that depends, right? And there are mixed results in some sense out there, where sometimes it works and sometimes it doesn't. So I guess I don't have a real good answer.
Come back to what we call hallucinations. Well, hallucinations are creativity. That is what LLMs do. We just make a value judgment about some of the things that they create. I mean, we call them hallucinations. So I mean, I agree very much with what William has just said. I think it's remarkable what LLMs, when you fine tune them, can do. Right, like code. Like you've got the Llama, you've got the general Llama models like Llama 3, but then you have Code Llama that's been fine tuned, right, for coding. It's quite impressive. And we fine tuned for mathematics. We've got machine learning models that I think solve all these Olympiad maths questions. There's something going on there. I mean, I'm not a machine learning researcher. I don't understand, but it feels a bit more than tab complete, right? What's going on? It's quite profound. One of my favorite uses, actually, for these LLMs is I program a lot in Haskell, and Haskell sometimes gives you incredibly hard to understand RMSGs to do some rigid variable A, etc. And it's the fact that I'm the world's first Glaswegian user of a Glasgow Haskell compiler. They still stump me. So what I do now is when I get an error like that, I just in Copilot ask it to fix the error or explain the error, and it's amazing how often it can actually do for Haskell, right? Not a super mainstream language. So I think there's something there.
So I wanted to come back to something both you said and that Sam said, that what's more impressive than LLMs in general is when you narrow the domain of the LLM to say code or to like a DSL. One of the experiments I love doing with the LLM is I ask it to give me a budget, and I explain the budget in natural language. And what it typically does, it will return this as an itemized list. It's like, okay, here's your budget. But then you can ask it to translate to new abstractions. Like, okay, translate this to a markdown table. Translate this to a CSV. And what's really remarkable is it will translate the structure and leave the data untouched. So it seems to have learned abstractions in a really fundamental way, better than it has learned like facts about the world. Right. So what it seems to be doing very well is learning structure. And I think that's kind of reflected even in English text, right? It has learned the structure of English language sentences. It has learned the structure of code. It's also learned that it knows how to translate between structures. It can translate like the budget from an itemized list to a markdown table to a CSV to whatever representation you want. Now, it will fill that with things like nonsensical totals that don't add up. But it really seems to understand the structure well, which is quite impressive.
A slightly different direction, again, trying to connect with PL, is one could imagine really trying to formalize the language in which you write the prompts. So currently we just write English, but you can get quite a long way with prompt engineering. I mean, there's all this sort of jailbreaking and so forth that people did in order to get LLMs to do things that they weren't supposed to do. But maybe we can take that further. I don't know.
See the work of Eric Meyer. Follow him on Twitter because he's advocating using data log-esque structured ways of prompting in order to get much better results from LLMs.
Yeah, I just want to say, I mean, I totally agree that if we're going to be programming these systems, we should maybe design a language in which we can write programs rather than using something as ambiguous as English language text.
Okay, I see several hands raised, but just want to do one summary, right? And because the first time somebody openly to me objecting the word hallucination, and he replaced with random. Although I think people probably don't think, I mean, really technically it's just statistically whatever comes next. But when there are multiple choices or equally statistically possible, that's sort of randomness come in, right? But I love this word that Satnam said, creativity, right? Something you dream up.
Yeah, I'm quoting Peter Dorwick. That's what he says.
Oh, Peter said that.
At Google, he says we should not concern hallucinations. What we're observing is creativity that we should celebrate.
Yeah. By the way, when the mic got passed back, and actually William has another word, nonsense, to characterize it. So I saw you were the first one who raised hand. Do you still have a question? Okay.
So I was interesting what you mentioned, Sam, about using the DSL as like I guess almost like a back end to the LLM. Something this just made me think about that not entirely uncontroversial idea in linguistics, the language acquisition device, like the Chomskyan idea. We have, something in our brain that helps us learn languages. I'm just wondering if, like everyone has been saying about, having some sort of structure, that we program in ourselves based on what we know we want. Could this work? Is this a way to actually reconcile, the semantic things that we like and the statistics things that I assume machine learning researchers like?
Yeah, that's the question. I don't know.
So I think this kind of relates, and I don't know who is familiar with algebraic effects. I know Sam is, for sure. But I think I watched one of your lectures, and you're talking about how algebraic effect handlers, what you program, if you're programming against the effect handler interface, you're creating a syntactic tree. And then the semantics of the handler define like a fold over that tree. And I'm just wondering if LLMs, if we split out the semantics and the control flow from the structure and the syntax of our programs, would there, do you think, or would you anticipate that they would produce better code or better able to separate the concerns of control flow and all of the different semantic nuances in behavior?
Seems like he's asking about the semantics.
Yeah, I think that's a very good question. I mean, it comes back to this idea that, well, the point that LLMs are just producing syntax. How do we, or if we have a natural way of programming in which there's a very distinct separation between the syntax and the semantics, can we leverage that somehow? Again, I don't know. Maybe.
Sorry for keep asking this question to Sam, but yeah, it's to do with the DSL part you mentioned before. As you said, I got what you said as giving some DSL improves some kind of AI in general. So, but as Brigitte said, it's hard to do that kind of things as a personal researcher. So, in general, and not just for Sam, but for all four of you, do you think does it make sense to put some effort on the making some DSL as a community so that we can use it for LLM?
So I think what LLMs are doing is that it opens the world to generate programs to many, many more people, especially people who are not necessarily trained to be programmers. Okay. Now, so if you think back of how we started to use things like search engines like Google, we also learned how to phrase certain questions, right, to get good results. Now, for LLMs, if you want to generate programs, we also need to learn, I think, how to phrase good questions. I mean, that's sort of implicit in way right now, where we sort of use prompts to maybe improve the answer. But ultimately, I think it's a certain way that we're asking to solve for a solution, for a program transformation, or more generally for a solution. Maybe the way we kind of split up a larger program, because we know they're sometimes not that great to generate really large programs. They're better in generating smaller chunks of programs, although they may get better. Or you know, when William was talking about, I start with the budget and then I ask it for these transformations, that's already splitting up the actual problem, right? It's doing some of the hard work of splitting up where they want, what kind of result we want in the end. So I think the bigger question is, how do we learn how to ask sort of the right questions, right? So that we get good results. And I think that has to do with sort of how we divide and conquer, so almost a problem, right? And how we kind of split up the problem in smaller chunks. Well, I think you can think of this as a DSL, if you like. Okay, I mean, it's basically, I mean, a structured way of asking the questions. And what is a structured way of asking questions? I mean, it is in some sense in DSL. It's maybe close to a natural language question, this DSL. But I really liked Andy Gordon's talk at, I don't know if some of you had seen at ICFP this year. So where he quoted Grace Hopper. Okay, so Grace Hopper was one of the first compiler writers, if you like. And she had this dream, right, that people would communicate in natural language the ideas they wanted to implement. And that was in some sense how she ended up designing Cobalt. But now, okay, you can actually ask in natural language the LLM for a piece of code. And so in some sense, you might say, well, haven't we achieved this dream, right, of generating programs out of a natural language specification? Yes, the natural language text is not precise, right? But it does generate often what matches our intention. And maybe we need to communicate our intentions better, right? Because as William was saying, well, maybe it's not hallucinating, right? It's just creative in what kind of results it will get. But we need to then decide what was our intention, and we'll pick the right result, right? But that problem is really that we need to be clear what our intentions are, even if we decide, right, to accept a certain answer or not.
Sure. I mean, I'll just answer different. I'll just follow the example of a Republican and Tory politicians and answer some other question I wish I'd been asked. Being a idealistic dreamer, I've always wished that the way we wrote software was this University of Oxford 80s style of stepwise refinement, where you start off with a specification and then you refine it, maybe in your theorem prover, step by step with proved correct transformations to get some efficient implementation. What a wonderful concept, but it only ever worked for quite simple programs and required people with PhDs at Oxford to do it. But maybe now we can do it, right? Maybe now we can democratize these kind of proofs, and we can have a co-pilot that could do all the kind of tedious steps. And now we can maybe take realistic programs, start with their specifications, which is a great bit of creativity that the humans bring to the table, and then the machine helps you with the video game of doing all the proofs and the sublemmas, driving that spec to an efficient implementation. I think that's the kind of crazy thing that I think that wasn't viable before. Maybe that is now becoming possibly viable because the LLMs is now can take care of the details, and more people could use technology like that.
I think something that's come up a few times, and particularly there, is this idea of a dialogue or a conversation or interactivity. And that certainly seems like a very powerful way of developing software. And we already have been doing that for years with proof assistants like Coq and Agda and so forth. But we don't get very much back from them. They just sort of say, these are all the types, or this is wrong. And you... more or less all of that creativity has to come from the human. But if we could make that more powerful, then yeah, I think that's a great idea. But I don't know how viable it is.
So I think one of the things that's very powerful about LLMs, which Brigitte and Satnam mentioned, is they democratize generating things that are otherwise quite complex. So generating code requires a lot of training. Generating, say, digital art requires quite a lot of training. And they make it very easy. And the hard part becomes, well, what they're doing is generating something from an ambiguous statement, right? So what they seem to be very good at is handling ambiguity. The downside to that is, well, if you've given an ambiguous statement, it will generate something, but it's of course unclear if it's what you meant because your statement was ambiguous, right? Because you were expressing yourselves in natural language. I think that's probably why, as we move to more formal languages, they get more precise. They get better if you tell it, well, generate a markdown file. Markdown is quite rigid. There's very little ambiguity in what a markdown file looks like. Although it will get all the data wrong because there is a lot of ambiguity in what the data of a markdown file is. I think that handling of ambiguity is very interesting to me. And one of the one of the failure modes is like you say, oh, generate a program in my favorite language, Racket, and it will sometimes do that, and it will sometimes generate totally invalid syntax. But the same is true if I tell a 110 student to write. 110 is our intro programming course. If I tell them to write a valid Racket program, they will often write invalid syntax, right? So it is performing a task that has a lot of ambiguity in it, and it's performing about as well as maybe a first year undergraduate, which is quite interesting. And what we seem to expect of the LLM is something we would never expect of a student, which is it should always perform perfectly. I don't even expect that of myself. I write invalid syntax sometimes, right? And what we haven't figured out how to do is integrate this system that acts very ambiguously, doesn't always generate perfect results, into our other systems where most of our computer systems we do expect to behave perfectly, right? We feed a program to a type system and we expect it to just check the rules systematically. And that's because it's something we have a lot of trouble doing ourselves. And I don't think we've figured out how to bridge this gap. But I think if we're going to try to integrate LLMs into something like PL, that is where it ends up being like, we need to interact with the LLM with all of our other deterministic tools in the same way that a human is interacting with these deterministic tools.
Sure. Thank you. I saw a couple of hands raised. We have only 10 minutes left, Barry, and one last. But I actually had one last question, and someone already answered, right? But we do that afterwards, like between this thing finish and whatever the Jane Street you want to go, which is what are your experiences trying LLM to do program transformation, not just do programming. Okay, so I won't ask that question, but it's fun. I did try. We're preparing the questions. Okay, but I have one most important question I will ask, and then they can ask, and they can choose what to answer. Okay, so basically, actually, Satnam and Brigitte indicate I've emphasized at the beginning, right? You get, now say, okay, I'm hallucinate or nonsense or creative, whatever it is, okay? But the point was, well, how do we make sure something was at least more reliable? So program verification, that's one of the biggest things this community has been studying, okay? And in fact, verification, sure, here's a program, but you need to verify against something, right? And people are already saying, separate DSL, whatever you intend. And so in fact, even at the Daphne, the day before, the workshop, right? Then people were saying, Daphne, right? That's the one verify against invariance. And say, where to generate invariance? Oh, we also use LLM to generate invariance, from English to invariance, and from English to code, and to verify. But those invariants are right? So how do we? So indeed, that's Satnam saying, I write specification, I write invariance, and that's what I want, okay? But he's highly capable of doing that, and Brigitte saying, let's teach students to do that instead of writing low-level code. Of course, Satnam followed up, if we can do this stepwise refinement even automatically, then we'll never have to write the lower-level things, okay? But ask your question. So how do we do that, right? How do we teach them?
My belief is that these LLMs are capable of doing all the craft work in the world, and the truly creative stuff is what will be left to us. But I think we can test this hypothesis in the following way. We often give a talk or write and we say, and now this step is done in the usual fashion. Yeah. So I think it might be interesting for all of us, whenever we're tempted to write that or say that, to actually think, can I get a machine to do this stuff in the usual fashion or not? and that gives us quite a spread of possible test cases beyond the things you might think of without any background. You're doing something rather complicated, and you think, well, I'm just going to use the techniques from this paper. Well, if you give the machine the paper and say, do the usual thing, it would be interesting to see what comes out.
Okay, let's get the last question, and then I said they can choose, and we'll finish.
Hello. So I'm kind of curious if, kind of on the theme of like accessibility for people without technical training, if the ways in which people use LLMs have influenced your thoughts on language design, because I think we've seen a lot of people using LLMs for trying to teach themselves something new or trying to debug errors and whatnot. And yeah, I'm just kind of broadly curious about how that plays into programming language design in your head.
Anyone want to start? Okay.
So I have two thoughts on this. Okay, so I think where I've seen that non-programmers, non-computer scientists are generating code is, this is an anecdote. Okay, my neighbor actually runs a shop. Okay, where she also has an online site where she sells various items, and she needs to update the description of these items. Okay, so for that she actually needs to generate some HTML code. Okay, and she uses LLMs to generate these kinds of little blurbs, which are little descriptions, as well as the HTML code that she needs to put there. Okay. And I mean, for that, I think it's a very viable thing, right? It makes her life easier. She's more productive. It's easier to update these websites and keep them so that they show up in the Google search engine quite highly. Okay. Now, for teaching, okay, so I'm teaching a functional programming course, and now last semester, I would say everyone used some large language model, okay, to generate the homework assignments where they didn't get any didn't get any credits for. And I have a student who ran all our homework assignments through through a series of these large language models, okay. And it turns out, yes, they vary a little bit in the code quality, but you know, they're very, very good. They would get basically an A- on all of our homework assignments, okay. Now, where large language models were not good in some sense, or were at least misleading, was in teaching concepts. Okay, so I also gave students some kind of conceptual questions. So, for example, generate an example, give me an example to highlight the difference between overriding and overshadowing. Okay, and as Annie was saying, right, you get the large language model generates a very long text. Okay, and the text might even have some good ideas. Okay, but it can also be completely wrong. And for students to assess, right, whether the answer is right or wrong, that is really, really difficult because they're just learning something. And so they have no reference, right, of comparing it to. So you can only really assess whether the answer is what you wanted or what the teacher wanted in this case or what this concept really meant, right, if you already have such an idea in your head. And so I think that is sort of the difficult part, right? It's much harder to understand something is not right. And that's for a novice. How, right? How would you do that? You need a sort of a trusted source that you can sort of rely on in order to learn new concepts. And so I'm a bit more skeptical essentially about sort of in the context of teaching and learning, right? What kind of role they actually can play. They certainly can play a role like of fixing type errors, what Satnam was saying, right? So I think students do that as well. Fixing syntax errors, fixing type errors. But it's almost like a drug, right? And so, yeah, it's easy, right? So then my question is, okay, if you don't, so I think Barry was saying it's a craft, okay, but in order to become sort of masterful in a particular technique, you need to learn a craft, I think. You need to learn the craft first. So my question is really like, how do you teach people still the craft, although they might not need the craft, right? See what I'm saying?
Coding is dead. Long live coding. So we see people use LLMs to make nice web interfaces. Lots of React code gets generated for you. I bet you almost never do you get exactly the right React code. So then you have to fix things up and get exactly what you want. You needed to have been a competent programmer. You needed to understand some basic principles of React and how it works in order to be able to do that kind of fix up. So LLMs are acting as a magnifier for your productivity as a programmer, not as a replacement for it.
I just want to comment on this idea that if you're doing the usual thing, then LLMs can be quite good at that. And that's sort of what. So in my compilers course, this is we ran a bunch of our assignments through the LLM, and after explaining like how they usually go, the LLM's quite good at generating something that's close to a solution. It's not very good, but it was enough to convince me that almost certainly all of the students will do this, and that means I can't rely on reading their implementation as a good assessment of what they've learned. Instead, I need to figure out, do they understand the creative aspects that go into the compiler design? And so we shifted away from purely assessing them based on the code they have implemented, and tried to figure out how do we assess them on whether they have learned some creative aspects that they could then explain. You then go and implement this in the usual way. Right. So now our final has a bunch of questions about, okay, suppose you want to extend your compiler, which of course you've implemented merely as practice. You could have used an LLM to generate it, but having actually implemented it, you will have also learned some concepts. Now, what would happen if you wanted to change the design to work this way? And all they have to do, they don't have to write any code. They have to explain that design and then tell us like, oh, and you would implement this in the usual way and that in the usual way, following the standard design. Right? And so far, this seems to be working well. We'll see at the end of the semester if it works perfectly. But I think shifting away from thinking of demonstrating that you understand something by following the usual pattern to inverting that and say, okay, do the creative bit, and then you're allowed to use an LLM, that's fine, to do the usual thing, right, the easy thing.
So what Brigitte said just reminded me of one of my own anecdotes, which is kind of inverted from what you might expect. So a couple of my undergrad students were doing projects involving effect handlers. And my postdoc was helping to supervise them and read some of the text that they produced and said, this looks like it was written by an LLM. And I'm pretty sure it wasn't, because I asked the students and said, did you write this or did you use an LLM? And they said, no, I wrote this. And I believe them. And I think, well, maybe that's capturing like part of the power of an LLM. What came up before, that they're pretty good at behaving like naive students who don't really know what they're talking about. This was trying to describe the difference between shallow and deep handlers, and it there was a sort of plausible description of what that might possibly mean, but it was clearly wrong. But yeah, it was interesting that they'd not used an LLM, but had fallen into the same kind of traps. But yeah, perhaps this kind of trying to describe some really quite difficult technical concept seems to be something that LLMs are not very good at the moment. Whereas the kind of thing that Barry is suggesting, maybe we can have these sort of mundane tasks be done by LLMs.
Okay, actually, I'll ask a last quick question for each of them. They just say one sentence, right? What should the semantics-based programming transformation community should do in the age of LLM? And you have 1 minute to think. And I just want to summarize one thing was from what I heard, not the answer to that question was, right, the first scaring question. And from what I just heard here, and of course I've seen before and thought before, was LLM, they're exactly complement to what semantics-based programming transformation doing. They're not going to replace us. Right? Started with what Sam saying, I don't think they're going to do it, and I think all their argument supports that. But now they have to ask the question, right? The visionary tell us, what should we do? And
I don't know, but I think I think what is absolutely crucial, and this has come up several times already, is that whatever we do, we need to have ways of getting assurance for whatever the LLM produces. So as long as you're in a setting where you can easily validate the output, then it's a really powerful tool. So thinking about how we get assurance.
Yeah. I think the thing I would probably do if I was spending much time at all on LLMs is try to extract what the LLM has learned in a way that I can be sure it has learned something. So try to get it to say, explain to me in a more formal language than English, what semantic transformation have you actually learned? Like, for example, the markdown to CSV. It has clearly learned something there, but if it could explain to me in formal language, I'd be more convinced that it has learned something meaningful.
Yeah, like Sam, all I know is about LLMs is how to multiply matrices fast. All this other stuff is above my head, so I don't think I have anything useful, meaningful to say.
I lost my train of thought here. Right. So I think what William was saying, I want the LLM to explain to me what it did. And I think that is actually, something very important because it allows us to check in some sense, right? If what it did matches in some form the intention of the programmer, right? Because, and so there was an interesting talk actually in this talk by Andy Gordon. So they were generating Excel code from natural language specification. So the user who's not a programmer would say, I want to extract the first column from this sheet 5 and I want to add it to the second column or whatever. And you might not, people might not remember all these Excel code, but so it would generate some Excel code after various kinds of steps. But then the question still is, right? How does the user know that this strange piece of code matches what they had intended? And so the step they had added was essentially an explanation, to return an explanation or extract an explanation from that piece of code. And I think that is actually something maybe we need to think about more, how we can sort of have explanations of the code. So it's a way of us testing whether students understood the code, but I guess it's also a way of trying to understand whether the model actually understood what we were asking.
Okay, thank you all so much. Actually, if I use one word to summarize, like semantics, that's what's missing, and all of them actually come up with this beautiful conclusion. So I like to let's always thank the panelists the first time.